everyone jokes about how bright it is. It is actually bright. Hello, NDC. Thank you for joining my session about the .NET supply chain. We're going to see a lot of different attack vectors today in which you are directly vulnerable for once you do nothing with your .NET applications. And I once heard that a good presentation is as good as the time it takes for the first demo. So let's start with the first demo. So I have this program.cs file where I have this simple application where I have this class. For the people who are looking at me, I'm quite tall and I need to bend over. So if you see me standing in a weird position, that's not because I have a backache or whatever. It's just I need to adjust myself a bit. I have this class called person, and I have this simple vibe coding. What I did, I just want to serialize this object to JSON and then log it to the command line. We'll see, hey, what could go wrong with this? I only use the, let's say if I do, for example, the .NET build, it will actually tell me, hey, everything's fine. I'm able to restore, it will compile, nothing wrong with this. So let's run it. And here you'll see, whoa. Well, you can imagine there are worse things that can happen than showing NDC Oslo what my worst taste of music is. I'm a Dutch guy, so I like Dutch music. It's not really in here, but yeah. But you can imagine if you look over the internet, there are much more examples of stuff happening to your application that you're not aware of, that it's introduced in your supply chain without you even knowing. Like for example, this malicious PyPy pack. Any Python developers here? Anyone who got their AWS key stolen by this package? No? It is serious threats. If you search over the internet, there are all kinds of examples of supply chain attacks and how they make us vulnerable. So how cool would it be that if I run that .NET build command, .NET will actually tell me, hey, there's something wrong. You should have a look at this, or you should have a look at that. That's what we're going to learn today, hopefully, and that's what my talk is about. So who am I? My name is Tom van den Berg. I'm a lead software engineer at a company called InfoSupport in the Netherlands. I work for the Dutch Railways for quite some time now, and there I build mission-critical software that makes the trains run every day in the Netherlands. So if you're ever going to visit the Netherlands and you have a delayed train, please don't call me. That's could be my issue, but hopefully not. Looking at history, the first time I came in contact with a supply chain attack was the SolarWinds attack. Not sure, did anyone heard of the SolarWinds attack? Right, where they built the software they built is called Orion, in which they provide certain features that is distributed to all kinds of governments all over the world. And the Orion software was breached via supply chain attack on their build server. So hackers, people who want to harm, got access to the build server and they added a backdoor to the Orion software, which was distributed to all kinds of governments. And so the hacker got access to all the governments that had that software running. A more recent example was the one from a Microsoft engineer who saved the world. And what happened here was that there is this great XC-utils package. I'm not sure if everyone heard of it. This is the contributor list of XC-utils, if my internet loads. Is this the day GitHub doesn't work? Oh, there it is. Cool. Maintainer is this guy called Larzu. And what you see here is a new maintainer that joined like in 2022 for the first time. And after that, he made some commits over the years, and he became one of the maintainers of this XC-util package. And this guy, no one knows who he actually is, but this guy built a backdoor into the XC-utils package, which is used in all Linux distributions all over the world. So you can imagine if this backdoor came into the Linux distributions that we're all using to run our software on, we would all be vulnerable for this. So I'm really thankful for that Microsoft dude who paid attention and saw this little CPU spike that he started investigating. But yeah, he might have saved the world from a very large supply chain attack. A new thing that occurred by the end of 2024 is the Cyber Resilience Act. Anyone heard of that? Not much people. That kind of warns me a bit, because there are a few things that you have to comply to according to this act. I think that you guys, is the same as me, has a lot of issue getting non-functional requirements like security on the backlog of your product team. Like, why do we need security? Once it goes wrong, then we'll start looking. This new Cyber Resilience Act is actually solving that issue. It's by law, you are required to have a certain security baseline in place, and you need to report on that as well. So the first thing you need to do is risk assessments. And that means that you need to provide evidence that there are no known vulnerabilities in the software that you deliver. You need to have security reviews in place. There needs to be some kind of documentation on how is your process fixing those issues. What is the assessment that you did? And do you have a bill of material, the software bill of material, which we're going to talk about later. There are going to be assessments. So your company, your product will be assessed. And there are several classes where your software will adhere to. If you're lucky or not, you can do a self-assessment if you're in the non-critical parts. But if you're in the critical parts of this law, you will get an independent auditor that comes to your company and actually will audit if you adhere to this law or not. And you're obligated to do vulnerability reporting. So if you found a new exploitable vulnerability, you're actually obligated to report it to the European NISA. You can Google it, what it stands for. But why it bothers me that you've never heard of it is because within 1.5 years, so by September 11th, 2026, you are all required to have vulnerability reporting in place. So I'm not sure if everyone looked around a bit when we raised our hands, if anyone heard of this, but you have almost a little more than a year to get this in place. If it's still not on your backlog, that can be quite warning, right? And these fines, when the auditors come by and you don't have this in place, the fines are way much higher than the ones that you get from the GDPR violations. So just to wake everyone up, hey, there's this new EU law that you might need to have a look at. Cool. Then the supply chain. A supply chain, everyone heard of that word before? Like it's in the car industry, all the irons that are made, and the rubber that's being put into your tires, everything that encompasses your product is part of your supply chain. The same is for software. So everything that all the materials, resources, and processes are combined in your product. And what's important in that is that 80% of the software that's currently running in production is no longer written by yourself. It's written by someone else, by some third-party dependency that we're using. Like, who's the .NET developer here? Oh, great, a lot of people. Who's a .NET developer that has never added a NuGet package to their project? No one, right? That encompasses, those dependencies are also part of your supply chain. And are you sure, do you know what those packages are actually doing? So looking at the .NET project, we have a lot of direct dependencies. And these are the dependencies that you directly put into your CS proj file that you can reference there and the things that you see. But there are also a lot of hidden transitive packages that come by. Like if you, for example, include mass transit, a great example, you get a lot of extra transitive packages for free. And a few years ago, does everyone know Log4j and what happened there? Like the critical issue that was found there. I got called a lot of times by a lot of managers, all in panic. Do we need to do something? Do we have Log4j? Do we have an issue? I was not sure. I was like, it could be somewhere in this tree. I'm not sure. I don't have the tools to see that. But what happens if one of those transitive dependencies has a vulnerability? Well, .NET has some cool stuff for it since the release of .NET 8. I'm gonna close this one up. So the first thing that you can just do is .NET list package include transitive. And this will tell you, hey, these are all your packages that your solution is using, including the transitive ones. Cool, right? Has anyone ever run this command to see what the tree actually is? Okay, cool. Something that's new in .NET 9. So let's say we have that log4j example, but in this case I take the system IO pipelines one. You have this new commando which is called .NET NuGet y. And with .NET NuGet y, you can actually ask, why do I have this dependency in my tree? So let's say I want to know where the system IO pipelines come from. It will actually tell me, hey, this is the tree via which I have this package in my project. If I've had this with a log4j issue, I could have just did this and then see directly, oh, I have a dependency on this via all these kinds of packages and I need to update them. But I didn't. I needed to go to Visual Studio, open the dependencies tab, and then open another tab and another, just to traverse the entire tree to see it. So something new. Who actually runs this kind of commands in their build pipeline or when they're developing locally? You do? Okay, cool. I don't want to do this. And that's why in .NET 8, there has been an introduction of NuGet audit. And NuGet audit is I'll just first show what this is doing. So I disabled it for demo purposes. The default configuration for .NET 8 is that it's on. So if everyone is on the version that got released of Visual Studio with .NET 8, you might have seen in your file explorer, you might have seen this warning where it states, hey, this solution contains vulnerabilities. That's this feature, which is enabled by default in .NET 8. So for now, if I do .NET build, for example, I will get warnings. And the warnings will actually state, hey, there are vulnerabilities found in packages that I have. At the same result that I would get if I did, for example, .NET list package vulnerable. See? Both the same result. Information that you will get from this is quite cool. I have a serious issue, so this. Okay. If there's a patch version for it, you can see, hey, I need to update to this, at least this version. You can, for some exploits, you can even see, is this all readable? I'm not sure if it's, yeah, good. Okay. For some exploits, you can even see, hey, this is how you can exploit it. So if you have any bad intentions, you can actually see, hey, this is the way I can misuse it. But what's really cool is a lot of people did, for example, the following. They treat warnings as errors. Everyone heard of that? Where you just say, hey, if I have a warning in my build, I can fill my build with an error. So the result of this will actually be, hey, build failure. Cool. Local development, I get at least a build failure when I have a vulnerability in my package. Well, that's the first step. In .NET 9, what's good to mention here is the audit mode. And audit mode is currently set to direct, which means it's only scanning your direct dependencies, so the ones that you have configured in your C Sports file. It's only scanning those ones for vulnerabilities. It was the same case at the first release of .NET 9. And in the second release of .NET 9, they changed this to all, which means I want to scan all the dependencies in my entire tree for vulnerabilities. This broke a lot of builds, because you can imagine if I have this treat warnings as errors set to true, and I get back onto work on Monday morning and they updated the .NET 9 and I updated the .NET 9.02, I got a breaking build. So they reversed that, but with the introduction of .NET 10, the default behavior will be that NuGet audit mode will be set to all. So once you update the .NET 10 preview 4, or when it comes out in November, you will actually have all your dependencies scanned by default. And the last thing that we actually have is the NuGet audit level, in which you can state, hey, I want to break my build on a certain level of vulnerability found. For demo purposes and to not have all kinds of errors and stuff that you need to filter out, I'm going to disable this again. Because another thing that was newly introduced in .NET 9 is the following. Restoring a project now outputs certain variables. And one of the variables is the project count. So how many projects are actually restored. And the second thing it outputs is how many of those projects are actually audited. Which means if I now, for example, I've disabled the vulnerability reporting on that project, and if I do now, for example, my .NET build, it will actually give me an error of a warning and says, hey, restore did not audit project. Not every project in the solution. Expected 1, found 0. So you will actually get information if your auditing has been done correctly, or did it miss anything. What's good to mention also is that if you're, for example, anyone who is only using a private feed for the NuGet packages, I see not so much people, so most of you are using the public feed, I think. But what you can do, or what you must do if you, for example, use a private feed only, is that in .NET 9, no, wait, one step back, the vulnerability information that .NET uses to give you the information is pulled from via NuGet, the public NuGet organization, and then from the GitHub advisory thingy. But if you have only configured a private feed for your packages, you won't get access to that information because you just completely killed the line to the public NuGet feed. What they added new in .NET 9 is this audit source thing, where you can actually say, hey, I only have a private feed configured for my package that I want to use, but for audit information, you can actually use the public NuGet feed. This audit sources is not used in, let's say, if I do the .NET list package is vulnerable, this is not using this audit sources configuration yet. They're still working on it. Okay, audit sources. Cool. Then we might be more secure, right? We have found out if we have any vulnerabilities there, we fix them. What could otherwise go wrong, right? Well, one of the things, was there already someone doing, who was doing IT before in the year 2008 already? I was not, I was barely walking then. No, that's not entirely true. Cisco, you know Cisco, the ones that built those little small routers that you had at home, the little blue thingy from earlier. Cisco was the first company, one of the first companies that actually got sued because they were using some kind of license in their software that forces them to open source their product. So this means that, let's say, if you look at the entire tree, one of those dependencies had a license in them, which actually states, hey, the use of this license will enforces you to open source the software that you use it in. And if you're using this in your core domain, like Cisco was doing, you were forced to open source your entire business product, the thing that you make money from, where competitors could be very interested in just taking it over. So you might see in the case of Cisco that there was a general public license somewhere down in a package that was very, that was published under this license. So they were sued. In the end, they actually got, they settled. It never came to an actual lawsuit, but yeah, they had to open source their software. Cool. So this is an issue for each and every one here. Has everyone heard of the license trap before? Does everyone know what type of licenses you have actually running in your current software? And do you monitor for it? So Linksys was kind of an Cisco was kind of an interesting company for people to sue because they had a kind of, I'm not sure what it actually was again, but they had this, they fixed something in Linux, I think it was, for some kind of networking stuff where the whole world was actually waiting for. So they were kind of an interesting company to sue and let them open source their software. But currently there is even a company now which is actually exploiting all these kinds of license violations by actually suing people, suing companies to that use this type of licenses and don't open source their software. Oh, I have a different view. So let me show you how this works in .NET. .NET itself doesn't really have a tool for this yet, so I'm going to use Trivy for it. But what you do need to do is need to enable my package log file, and I'll come back to later what this actually is and what this means. But this will generate a certain file which contains all kinds of information about my dependencies. So if I now, for example, run Trivy with a certain scanner, everyone heard of Trivy before? Like, it's an open source scanning tool which scans for misconfiguration, vulnerabilities, licenses, all kinds of stuff you want to scan. Scanners, license. So this will actually tell me, hey, I found your package log file, and these are the licenses that you're currently having via all the dependencies that you're pulling in. That's something you can just run today, tomorrow, when you get back to the office and see, hey, what kind of dependencies and what kind of licenses do I actually have? In this case, I only have the BS3 and the MIT one, so the severity is kind of low, but you might see if you have other licenses in your software, that it will actually tell you that you might have an issue, and that you might need to look at some certain stuff. Cool. And that's why one part of the Cyber Resilience Act is having risk assessment in place, having supply chain risk management, which means identifying, assessing, and prioritizing all the risks that you introduce by adding dependencies to your software. So you can think of, for example, operational risk, financial risks, business continuity risks. Do we want to trust that open source maintainer from Nebraska always will support this package and my core business will rely on it? Or do I need to write it myself? A great example of this is, and I know it started out as some kind of geek thingy. I'm not sure where it is. Has everyone heard of the is-odd package from NPM? This is quite a cool package. This tells me if a number is odd or even, right? It has almost 400,000 downloads a week. And what's really cool, if you look at the code, it's like 13 lines of code. So if your core business relies on a package like this, you might want to see, hey, isn't it better to implement it ourselves? And spend some time on it to implement it. It might not even be that hard to do. And what's really cool is that this one also has a dependency to isNumber, which has 92 million downloads a week. And this will actually check if the thing that you have is a number. Right? Like, why would you trust on this? Do risk assessment, see why you use certain packages, and make sure you use it in the right way, and that you accept the risk that you introduce with them. Cool. So we figured it out. We have to fix the license trap. We don't have any known vulnerabilities in our software. Cool. We're safe, right? Not entirely, because I just asked how many people are just using a private feed, how many people are only using the public NuGet feed, how many people have some kind of combination like this, where you have a private and a public feed. Oh, cool. Two types of supply chain attacks I want to discuss with here. The first one is dependency confusion. And looking at this, let's say, for example, I have this package, my cool package, that's being used, and that's being published to my own private feed. And if you say, hey, NuGet, restore my packages, what NuGet will do is it will send an asynchronous request to all the configured package sources, and the one that has it returns it, right? That's how we're currently doing this. But what's the issue with this is that NuGet sends an asynchronous request to all package sources. And if I say, for example, hey, I will publish as a hacker or someone who wants to do harm, if I publish a package to the public NuGet feed that has the same name as the package that you are using, and then rely on the internal working of NuGet that selects the package or the package source that returns the fastest response, I'm just going to wait and see when you are going to pull my package instead of using your own. Right? This is a serious risk that everyone, I saw a lot of hands where everyone's currently actually vulnerable for. Another thing, who uses wildcards in their references? Oh, that's great. Oh, only a few people. But the same is for wildcards, for example. I can just upload a version that's way, way, way much higher than the one that you're currently referencing, and you will always pull my package, for example. So dependency confusion. What I will demo is what NuGet has in place to be more resilient against this. And the second thing is the typo squatting attack, what I will show you. So the first thing that you can actually do, and I'm really curious how many people already did this. This is just a NuGet public NuGet feed. And the thing that you see here is this prefix reserved keyword. Has everyone ever seen this before? Cool. Prefix reserved actually means the prefix, and you can define yourself what your prefix actually is, but in this case it's the prefix Newtonsoft, is reserved for the company or for an identity that solely has the rights to publish packages in that name that contains that prefix. So you can imagine, I work for the Dutch Railways, in short it's NS in the Netherlands, that I want as a company to claim the prefix NS so that no other person or whatever can publish a package to that feed in my name. It has that prefix of NS in the beginning. Now, if you click on this, you will actually be routed to the process of doing this. And the funny thing is that it's quite a weird process. It just starts by sending an email to NuGet. Like, what? But yeah, package prefix claiming. If you're using the public NuGet feed and a private feed, I would definitely recommend you doing it starting from Monday as well. The second thing that you can do against dependency confusion is in your NuGet file, in your NuGet configuration file, there's this thing called package source mapping. And package source mapping is actually a mapping of where you want to pull your packages from. So let's say in this example, I harmed myself a bit by using my own version of Newtonsoft JSON that I altered a little bit. But to show you what it actually does, if I move it to here, for example, and what I first need to do, so NuGet actually uses a local cache as well to restore packages. And the first thing it actually does is check that local cache if the package is actually there. And it doesn't really matter from which source it actually came. If it's present in your local cache, it will use that version. So now, because I have my malicious version of Newtonsoft in my local cache, I cleared it. And if I do, for example, now a .NET run of my project, and then it needs to restore everything again because I just cleared all my cache, which takes a bit longer. Oh, this is correct because I still have my package log file enabled, and you already saw the demo of what the package log file is about. I'm gonna disable this one and delete that one, which we'll come back to in a bit. But now again, cool. Build succeeded. And it actually outputs without changing anything in my code, I just changed the package reference where I want to pull this image from, or where I want to pull this dependency from. It actually works, and it does what I expect it to do. So package source mapping. Then I'm a CLI guy. I use a lot of Visual Studio Code and the CLI. Are there people who add in to use the command like .NET add package, for example? Are there other people who add packages like this, or do you always use the Visual Studio thing? Okay. Typo squatting attacks actually do as the name says. They rely on people making typos. Like for example, in this case, I want to add the package poly.core. You already saw me make a lot of mistakes typing this small sentence here. But what I can do as an attacker, or if someone wants to do harm, is I can publish malicious packages to the public NuGet feed and actually introduce some kind of typo in the name, where I will rely on people actually making mistakes in adding those packages and attack them via there. So I can just publish this one and make a reference to the actual poly core package. So the functionality will always be the same. But I do have a package that's mine and not the one that you're expecting to be. So something you can do against the typo squatting attacks, and that is also in my NuGet config file, which is signature validation mode. And with signature validation mode, you tell NuGet to validate the signature of a NuGet package that you're actually using. And this uses the trusted signers that you can configure in your NuGet config as well. This will actually check, let's say for example, I have an author or a certain repository. There are two different types of trusted signers that you can add. But one of those, of the package that I'm pulling in, needs to have a fingerprint that is the same as the one that I have configured here somewhere. Otherwise, it will actually fail. Now what's interesting, are there any .NET MAUI developers here who are also publishing to Apple, macOS thingy? No one? Wow. Trusted signers is currently broken on macOS. There's this bug that has been there since 2022, where Apple made some kind of changes in the encryption they do on Macs. So I can just remove a, let's say I'm going to remove it here. And then my project will still be working. But if I go to my Linux build server, for example, where I also ran this example, it will actually state, hey, you're not able to do this because some kind of trusted signers are actually missing. So it doesn't work on Mac. There is this bug on NuGet, of on GitHub, that you can find more information about. I will link after.
This is in theory very simple. You just need to get the fingerprint of all the certificates and all the authorities and all the suppliers and all the feeds.
Yeah.
And that sounds like a lot of work.
It does.
How can you get this easy?
Yeah, there are two ways to add these trusted signers. If you add the signature validation mode and then just run your software, it will actually state, hey, these are the packages I'm trying to, sorry, did everyone hear the question? Sorry, I'll come back to the answer. The question actually was, hey, we have a lot of NuGet packages there and a lot of dependencies that are into it because it's all from the entire tree needs to be configured. How do we do this? There's a lot of packages there. How do we fix this? It's quite some work, I can say that, but yeah, security needs some attention as well. What you can do, there are two things. You can use the .NET trusted signers command. I'm not sure by head what it is, but there's a command where you can just reference a certain package that you want to trust. Or if you remove it like this here, it will actually output the hash of all the packages it will download and then add it to here. So there are certain ways that you can find out of it, but it does take some work. You don't have some kind of wildcard that you can just add and then it magically works. Is that an answer to your question? Ish. Okay. Maybe come back after to discuss it a bit more. Typo squatting attacks, add trusted signers to be sure that the packages that you're actually pulling in are from the publishers that you will actually expect them from to be. Cool. Now, we have fixed all local vulnerabilities. We're sure that the packages that we're actually using in our local development are the ones that we expect them to be. We have checked all licenses and everything's okay. We're safe, right? What's interesting is that we then push our software to the build agent, and the agent goes beep, beep, boop, 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 and there comes some kind of binaries out of that. And for .NET, there are, no, one step back. What you want to have is that the binaries that come out of your local deployment or local development are the same binaries that come out of your build agent, right? They need to be the same to be deterministic. And deterministic builds are called reproducible builds, and there are a few things that actually influence the outcome of that build, which is the installed .NET version, so which SDK version have you installed on your build agent and on your machine. What packages are being used, what versions of packages, what's the content of them, and what's in your local cache. So you can see, for example, in case of the SolarWinds attack that I described in the beginning of this talk, that there was some kind of malicious package added to your local cache, which was then being used in the restore process, which you're not aware of because it's running on your build machine, like, and you don't have stuff enabled to check this kind of stuff. That's kind of hard. Like the build agent is actually a attack vector that you need to, of an attack service that you need to secure as well. So reproducible builds. What's in it in .NET? There are a few things. Let me take this a bit back. Yeah. Okay. One of the first things we need to do is the package, go back to the package log.json. So the package log.js, who's not enabled the package log.json in their project? So everyone knows what the package log is, and cool. For the ones who don't have it, it will generate a log file, and that log file contains certain versions, the version that's being resolved and the content hash of the package that's being resolved. And if you then, for example, this log file, you need to check into your source control, and then what you can do is do a restore including that log mode, which you actually say, hey, I want to use this package log file to restore my packages and check all the stuff that you restore to the content that's being described in that log file. So in this case, I didn't change anything. I still have that warning of the restore did not output, but my build succeeds. But if I, for example, say, hey, I want to use a newer version, if I get access to the build agent, I say, hey, but my malicious package is 13.04, and I update it before the build actually starts, and I run this again, and we already saw it in previous run, it will actually fail my build as well. So having 7 different dependencies locally on the build server, this will actually fail your build for that. And we'll make sure that you have the same binary outputs as well. Another thing that, oh, that's the wrong one. Another thing that happens, that can happen, or can influence it, is the software that's already present on that build agent. So there is this amazing package which is called .NET Reproducible Builds. And there are a few things I want to highlight from that. And the first thing is this netcore target pack route, in which states that the .NET build will actually sniff out installed software on your machine and use that runtime, the .NET runtime that's installed to create the binaries, create your package for you. But the runtime can be messed with as well. I can log into that folder that's being described, and I can alter the runtime there. And the thing that you can do is this netcore targeting pack route, set it to undefined. What MS-build then will do, it will pull in a NuGet package, which contains the runtime that's being used for building your binaries. So this is what you see here. And to show you that it actually works, say, for example, if I go back to my NuGet config file, that's why I have all these configured here. Oh, let's say, back. Let's say I remove those. Remove all my local packages, and then say .NET build. See? And now it actually states unable to resolve this package. Package source mapping is enabled and it's not configured. So putting this back. So this will actually use, and these NuGet packages are also part of your package log file, in which you can just say, hey, and they are being checked in the process with trusted signers, and everything that I showed you before is also used in this process. So you're sure that the NuGet packages that I use locally to build, the runtime packages that I use locally to create my binaries, are the same ones that I'm using on my build agent to create the binaries there. And the last thing for this I want to show you is there's also this implicit NuGet fallback. You have that NuGet cache where you can put stuff for. You can disable that by setting these properties. Okay. So what we actually did in the past 40 minutes, I think, is create a secure by design .NET solution where we have NuGet audit in place to check for vulnerabilities, claim the prefix where we don't allow other people to actually deploy certain stuff for us. We checked for all the licenses that we have in place and if there are no known issues with that. We enabled package source mapping to make sure that everything comes from the right place. Checked for pre-installed software and used the specific ones that we defined. Saw the package log file that checks the content hash and if it's the same package is correct. And we saw the NuGet cache and what can happen with that. And we disabled it. So what we actually did is create an automatic or a secure by design solution where anyone can just add a package. And if it's a trusted package, it will just work. But if it's an untrusted package that comes from a separate source that you don't expect it to be, it will automatically fail. So by default, anyone who wants to work with this has a more secure way of using it. So if you have any junior developer or whatever, it can't just add some kind of a random package and then break the whole stuff. So what's more importantly in this is that you also need to create the transparency. Yeah? And for the Cyber Resilience Act, we also stated that the service bill of material, of the software bill of material, is a real thing, and that needs to be report out. You need to report out on that and show what's all there. So to show you what is actually a bill of material, I will use Trivy again. And for this, I will include the license scanning and the vulnerability scanning. So running this. Let's see if I have my package log still enabled. Yep. Okay, this outputs my JSON file. And what's good to mention is there are certain different types of formats for SBOMs. We're not going to dive into that, but the ones that I'm using here is the Cyclone DX one, but there is also SPDX. They have the different strengths, a lot of overlap in them, but yeah, they have different use cases. So what's interesting is that this information contains all the licenses that are being used in your software. It contains all vulnerabilities that are being used in your software, and you want to report out on this. But what is something that's quite newish is an SBOM-related concept, which is called VEX. It's the Vulnerability Exploitability Exchange. And what VEX actually does is it puts all the vulnerabilities that you have in your software in context for the end user, for the ones who is using your software. So let's say we have this vulnerability and SBOM combination, which says, hey, I have like 200 vulnerabilities in my system. If I then add a VEX for it and see, hey, what of the 200 vulnerabilities that are actually there are exploitable in my software, I can slim it down to, for example, 5. So let's say I have 100 vulnerabilities that are found in packages that I don't even ship to my customer. And another 50 packages of another 50 vulnerabilities are found in endpoints that are not even exposed to the outside world. What type of vulnerabilities are actually exploitable for the end user? That's what we want to report out on, and those are the interesting vulnerabilities as well to fix at first. So that's the combination of an SBOM file and VEX. There's a lot of more information to find about it, but I want to at least touch upon the subject and let you know that it's out there and something you need to look into. And the last thing I want to show you is Salsa, which is an open source framework provided by Google. It contains a checklist of all for the entire software development lifecycle, where it states, hey, for each part of this lifecycle, what are the attack surfaces that you have, and what are the things that you can do to actually be more secure in your entire process. To round up, what we've learned, we've seen different types of supply chain attacks in .NET and how you can fix them. We've seen supply chain risk management, where you actually need to have some kind of process in place to determine, are these the dependencies I really want to add? Secure by design implementation in .NET with all the examples I gave. And creating transparency by creating an SBOM file and reporting out on it. But you can't forget everything, and it's all important to fix. But if there's one thing I want you to remember and want to create a call to action for it, is get started today to run your .NET list package, include transitive vulnerable for it, to see if you have any vulnerabilities in your software and start fixing them today. Thanks for listening. That was my session.